Okay, this is question number 16 from your day 3 homework of Unit 5, Lesson 1. This comes on page 342. So 16 reads, graphs of quadratic polynomial functions have one basic shape, a parabola. For high-degree polynomials, graphs of two polynomial functions of the same degree can have different shapes. Part A says, how does the basic shape of a quadratic polynomial function explain why quadratic functions can have 0, 1, or 2 zeros? Well, zeros of a function are where they cross the x-intercept. So if I think about a parabola, let me draw you a graph here. If I drew this parabola, this would be no zeros, right? That parabola never intercepts the x-axis, so it would have no zeros. Now if I take the parabola again and I move it down so it's just touching one time, then it has 1 0. Okay, or if I draw one more picture for you here of a parabola intersecting the x-axis, sure enough, now I have 2 zeros. Okay, and so then we have the different options. Okay, no zeros, 1 0, or 2 zeros. So that kind of explains how that works. It just depends how many times it intersects the x-axis. Part B, find a cubic degree 3 polynomial function whose graph matches that shown in each case. Oh, so you have to do a curve fitting tool here. So the first part, we're given this curve, and maybe you can see it, but there's a maximum and a minimum, and we know that this is cubic. We're going to have 3 points from this cubic. So I'm going to select those 3 points. I'm going to select, it looks like negative 2, 0 is a good point. Looks like 0, 0 is a good point. And then one other one I have is actually the point 2, 0. So I could go back to the methods that we used for curve fitting tools, but I'm going to do something a little different this time. Since this lesson was more to do with the x-intercepts and how those x-intercepts relate to factors, what I'm going to do is write this out in factored format instead. So I'm going to write my factors as opposite the zeros. One of my factors should be x plus 2. Another one should be, well, with 0, it would just be x plus 0 or minus 0. And then this last one is x opposite to positive 2 would be minus 2. Now this x plus 0 is just x, and I'm actually going to move that to the front and write this as x times x plus 2 times x minus 2. Now I should verify that this fits by putting in another point. You might have noticed that the point negative 1, positive 4 should be on this graph. So I should verify that. So I'm going to check to see if negative 1, 4 is on this graph. So I'm going to put a negative 1 times negative 1 minus 2, negative 1, this goes to positive 1, and then negative 1 minus 2 is at 3. Okay, so negative 3 times 1 times negative 1 again is, this is actually going to be 4, or actually 3, not 4. Okay, so we wanted 4, so this didn't work out right. So we've got to actually multiply by something else yet. We need a stretch in this case so that negative 1, positive 4 shows up. All right, so what we have to do is if we get this 3, not 4, then we have to actually multiply k value. And so that k value needs to go on there. So now we're going to set the k value up. So we have 4 equals k, and then we put in all our values. We put in negative 1 again, we get negative 1, and then we have negative 1 plus 2, and then on this part we have negative 1 minus 2. So we already knew that this yields a negative, or a positive 3. Okay, and positive 3k equals 4. Divide by 3, I get 4/3 k. So I should throw that in the front. So I now have my expression as y equals 4/3 times x plus 2 times x minus 2. And that expression will fit this data. Okay, let's try the second one. In the second one, I have a cubic again, but here's a slight problem. In this expression, I don't have any zeros other than 0, 0. So I know my intercept is 0, 0. So it's kind of like an x to the third expression, except this x to the third graph looks like it's been shifted, moved. All right, and it looks like it's been moved from 0, 0 up 1 at least. So it looks like I've at least added 1 to this. But even x cubed minus 1 wouldn't look like that expression. Okay, and so then I got to do a little bit more work. It looks like it's been moved over 2 units to the right. Well, maybe from previous work, you might remember that if you do something to the x, if you add values to the x, it moves left. And if you subtract values to the x, it moves right. So let's do this. Let's write this as x minus 2 cubed plus 1 on the end. Now, I know what you might be thinking. You might be thinking, well, Mr. Meyer, that doesn't work out well because this would mean that 2 should have been a 0. Well, careful. This has added 1 to it. So 2 wouldn't be a 0. 2 is where the 0 used to be, but it's been moved up. So this is now up at 2, 1. Oop, I got to be careful here too. 2 is out there. That's only a shift over of 1. So I got to watch my graph here. This isn't a 2. It should be a 1. So I think this expression is going to work. But let's check it. X minus 1 cubed plus 1. Let's check it by finding a value that should exist on this curve right now. And it looks like 2 should be on this curve. So let's check it. Is 2 on the curve? I'm going to check. So let's put 2 in. 2 minus 1 cubed plus 1. 2 minus 1 is 1. 1 cubed plus 1. 1 cubed is 1. 1 plus 1 is equal to 2. So it turns out that 2 checks. So this curve does work. That's my expression. I'm happy with that so far. And then part C says, as each curve is shifted vertically, what happens to the number of zeros of the corresponding function? Well, on the first one on the left, as this goes up, if you were to move this up, this one on the left, this line or this curve continues forever negative. So I'm always going to have one intersection there. But over here, this is going to move from being 2 intersections to eventually 1 intersection to eventually no intersections. So what's going to happen is the zeros are going to shift from 3 to 2 to 1 on the left. And then on the right, the one on the right, it will always just have 1 as you shift it up. Zeros are always 1. Okay. Part D says, what are the possible numbers of zeros for any cubic polynomial function? Well, it looks like the cubic can have 1, never 0, 1. It can have 2, or it can have up to 3. There will not be able to have 4. So we have 1, 2, or 3 solutions. And that ends this homework set.